This is section 2, lesson 3 of unit 3. In this section we look at kinetic energy, and as you maybe guessed by the picture here, kinetic energy is energy due to movement. So it's due to the motion of the object and depends upon two factors, the mass of the object and the object's velocity. Kinetic energy is calculated using formula EK equals half mv squared, and the mass should be in kilograms and velocity has to be in meters per second. And the unit for kinetic energy is joule. Now this is what's called a squared formula. So we take notice here we have two variables. We have mass and velocity. If the velocity increases by 3 times, its kinetic energy will increase by 9. And here's the reason why you would get that increase. Let's say if you had an example, the mass of the object was 2 kilograms and its velocity was 1 meter per second. You would have 2 joules of energy. But if you take the velocity, increase it 3 times, so mass stayed the same, but you take the velocity now and increase it by 3. So 1 times 3, and that gets squared, so 2 times 9. The energy now changes to 18 joules as compared to having 2 joules. And if you make a comparison, well, you get 18 joules as compared to 2. 18 divided by 2, it went up by 9 times. The reason being is that it's being squared. So we will call that a square factor. Right there. Now with example 1, you're told a curling stone with a mass of 6.36 kilograms slides across the ice at 1.5 meters per second and find its kinetic energy. Formula half mv squared, and we do know the mass and the velocity. So you input both. Don't forget to square the mass first, then multiply by 6.36 and multiply by half. And you come back with a final velocity of 7.155 joules, or rounding to significant figures, 7.2 joules. If the velocity of stone will increase to 3 meters per second, what would be its kinetic energy? So the mass remains unchanged, so we've doubled the velocity, and we have 29 joules. And compare the change in kinetic energy for parts A and B. So initially we had 7.2 joules, doubling its velocity, changed the energy to 29, which is what we've done here. So initially the velocity V2 went to 3 meters per second. The initial velocity was 1.5, so it was a doubling of the velocity. And by doubling the velocity, what happened to the kinetic energy? Your kinetic energy was 28.62. Initially it was 7.14, and your kinetic energy went up by 4 times the amount. And the reason being is because of the squaring in the formula. That because the velocity gets squared, the amount that we increased it by, also squared. So again, it was doubled, but the doubling was squared, which gave us 4 times the amount.